All right, we're going to start chapter 5 with loops. I'm going to do the same thing. I'm going to cut this into sections with the examples, and we'll work our way going across. So loops is really where the power of computers start coming into play. We're going to get to the point where we can repeat code. So this was actually a very common program when I started programming. Was loops were introduced very early on. You would get a hello world or a hello program that would show you how to print to the screen, and then in one of the secondary things you would do is you'd learn how to repeat it multiple times. And so the idea here is that if we have something like welcome to Java, but we want to print it 10 times out on the screen. Now or 100 times in this case, we could write the code so that system.out.println welcome to Java, and we write that in 100 lines of code. Now, for some compiled software, this takes up a lot of memory, because what's going to happen is welcome to Java is going to be in memory, and then in the pushing it to the screen will be commands that happen within the CPU usage. So this will run really, really quick because it goes right through memory, but it takes up a lot of memory. But a thing we can do is we can ask the program to repeat itself. We can ask the program to go back and repeat a command. Now, in the machine language that gets built, what happens is each command in the executable is in a memory address, and the code points to a memory address earlier in the code, and it jumps back up to that memory address and restarts running the code in order. But to know when we need to exit the repeat, we need to count. We need to count to 100. And so we have to add some if statements and some comparisons, which actually slow down the execution a little bit. So the trade-off for loops is they run a little bit slower in machine code. Not much from the speed we're going at, but they take a lot less memory. And back when I worked with Linux systems, there was a build your own Linux system, and one of the commands you can get for the C compilers, you can unroll a loop. If a loop's being repeated, you can get it to be one set of commands instead of having that check, and that will speed things up on certain operations. So there's a trade-off, which you will see in larger data and larger programs, is that loops use less memory. They're easier to read, they're easier to code, and there's a good axiom in coding is never repeat writing the same thing more than once. And so loops are a way to keep repetition. But the trade-off is they run just a tad bit slower on a machine level. So depending on how you loop, there can be some inefficiencies with them. And a lot of how we program is a balancing between how much memory we take up versus the speed of execution. So a loop looks like this. In this case, we are setting into the memory space integer equals 0, and then in while count less than 100. So the while count less than 100 part of this is a comparison operation. It's doing a comparison that checks the value of count, and if it's less than 100, or if that comparison is true, it's going to execute what's inside these blocks here. Because what's inside those blocks are what we want to run. And so they will run on on the truth. If it's false, then the while statement will skip this block of code completely and pop on and run whatever code's necessary. So these blocking statements are like running an if count is less than 100, do this. Otherwise, run what's next. But what happens is when it's true, when it gets to the end of the block, instead of running what's next, because of the while statement, the program jumps back up to here, runs the test again. So if we do not have a count being added, if we do not change count inside of this block, this will run forever because nothing changes count. But by adding a plus plus, count starts at 0. The first time through, it goes up to 1, comes back up and compares it less than 100 and keeps running. So the structure of a loop is a section of code that will repeat, and it repeats based off of a condition here. And so the while loop checks that. And so that's going to be our solution for running multiple pieces of code. What this looks like in a flow diagram is the loop condition is a conditional. And if it's true, it does the statements inside of the loop body. If it's false, it exits and moves further on down the code. But once the statements are done, instead of falling to the next part of the code, the flow goes back to where it was before the loop. So specifically, in this counting program, count equals 0, it checks if count is less than 100. As soon as count equals 100 or anything larger, it's false, and it leaves. But because we come in with count equals 0, that's true. It prints welcome to Java. We increase count by 1. It comes back up to here, and it's time to compare count to 100 again. Now, in this small while loop, if we work our way through what the logic of the program is doing, when we initially set count equals to 0, so we have a memory location that equals 0. Then the while statement goes in, and it's going to say, is count less than 0? So we go, hey, or less than 2, I'm sorry. And that's true. So being true, then the body of the code runs, and we update count plus plus. So now count is increased by 1, and count is now 1. We're going to fall to the end of the brace, and that's the end of the looping block. So it's going to pop back up to the beginning, and it's going to say, okay, well, is count less than 2? Well, 1 is less than 2. So it comes back in, prints welcome to Java again, increases the count by 1, and it's now 2. Then it comes back up to here. Well, 2 is not less than 2. And so it's false. So the next step of the program is to jump to whatever code is below that block. And so that's the basic structure of a loop. What we're going to do here is the example program I'm going to do is I'm going to do a guessing numbers game. And the guessing numbers game is we're going to make a random integer between 0 and 100. Then we're going to prompt the user to continuously guess the number between 0 and 100 inclusive. And if they're wrong, we'll tell them if they're low or high. And if they're right, we'll print right and leave the loop, and the program will end. So we're going to make this our program for our first example. So I'll pop this up in our video lectures, and then I'll do our example program.